Welcome to the Basics of Fiberglass. It's a pleasure to show you how some of our customers made their ideas happen using our products. Mark Frankel had an idea. Now other modelers take his ideas and make ideas happen too. David Penry built his own model. Unique ideas are made to happen with fiberglass. Crawford Boat Building has made hundreds of ideas happen, and memories too. Some ideas mimic real life. Creative Fiberglass takes real life and makes it happen anywhere. Creative Contours takes real life and mimics it, even in your own backyard. I met Jim Steiner. His years of enjoyment flying this airplane made quite an impression on me. The Michael Bronstein Group closed the book on impressing the neighbors with their version of a lawn mowing machine. Dave Golick caught the fever. High can always be higher. Lewis L. Enterprises, idea maker by nights and weekends. You can't help but love it. Real ideas, real pilots. Model Specialties makes powerful ideas happen. Power, speed, training, and timing. Skills that can be learned and skills that can be envied. Malcolm Lovelace, Curtis Williams, and Fiberglass's own Jim McClay made this idea happen. Power, speed, training, and timing. We can teach you the skills needed to make your ideas happen. We can help you build it, perfect it, make it faster and lighter. The ideas and making it happen are up to you. Hi, I'm Marilyn Widener, President and owner of Fiberglass Developments. The video you are about to see was developed for someone who is new to fiberglass work. What are resins and reinforcements? And how does someone make an idea happen with fiberglass? To understand fiberglass, let's look at composites and plastics and see how it fits in. First, wood is the original composite. The wood fiber and sap come together to form something much stronger than either component individually. The fiber and sap bond mechanically and chemically. Composite technology is based on the same principle. We want to make something stronger and lighter for the weight than wood or metal or other materials. Fiberglass is a composite. Fiberglass is also a type of plastic. It is a reinforced plastic which makes it stronger than other types of plastics. Trash bags and shampoo bottles crumple easily. Boats and airplanes do not. Fiberglass is a reinforced plastic. Additionally, fiberglass allows the ordinary person to make one of a thing. Unlike other types of plastics, you can make one by hand. With fiberglass, you can make your ideas happen with practice. Without equipment or a major investment, you can make 1 or 1,000 of complex shapes, boats, airplanes, sculptures, exhibits, virtually anything you can imagine. This video is designed to be informational. It is an introduction to the materials and techniques involved in making your ideas happen. This video was not designed to be instructional. We are not trying to show you how to make a certain thing, but to show the variety of products which need to be considered so that you can progress to the next step, which is designing your product, determining what materials, tools, and supplies are most appropriate, and identifying the fabrication technique which best fits your application. There is nothing so difficult about fiberglass work that the ordinary person cannot use these products and techniques. In fact, most people are surprised at how easy it is. Most people are able to produce simple and complex projects and repairs in their own basement or garage. As with any project which involves chemicals, safety considerations are very important. I will discuss safety considerations throughout this video and review them at the end. You might also wish to refer to our catalog throughout this video. It offers a more detailed description of each of these materials. Remember that we are happy to answer your questions about our materials and any aspect of your project. Please keep your project in mind as you watch this video. Fiberglass is composed of two basic ingredients, resins and reinforcement. You must carefully select the correct resin and the correct reinforcement for your application. First, we'll discuss resins, then reinforcements, and then look at how they come together to make the fiberglass repair or fabrication. There are two types of resin commonly used in fabrications made by hand, polyesters and epoxy. Both of these resins are liquids and turn into solids by the addition of a hardener. Polyester resins are less expensive and easier to use than epoxies. That is why most boats, snowmobiles, showers, and sculptures are made with polyester resin. It is also naturally resistant to ultraviolet light and is used in most swimming pools and decks. Epoxy resin is usually stronger and more impact resistant than polyester. It is commonly used in skis, airplanes, and high-performance cars. After selecting polyester or epoxy resin, there are additional choices to make. To help you make a wise decision, there are some terms which are helpful to understand. Pot life is the length of time you have before the resin starts to solidify. A 20-minute pot life means that the resin will start to cure in about 20 minutes after adding the hardener. Curing means hardening, except that the actual full curing process takes longer than what you can see or touch. Although most resins begin to cure in 20 minutes, the full chemical reaction takes about 48 hours. Therefore, a boat should not be put into water or a mold should not be used until the full cure cycle has been completed. It is important to know the full cure time of the resin you have selected. There are several types of polyester and several types of epoxy resins. The proper selection depends on the application. Gel coats or surface coats are typically selected with the resin system. These specially formulated resins are used on the exterior surface, primarily for appearance of the finished part. They color the part. They offer gloss and they hide the pattern of the reinforcement. Very rarely would a person not mind if the pattern of the reinforcement showed through. Pigments are added to resins and gel coats to color the material. The liquid pigment is stirred into the resin and will provide an opaque color, which is also often desirable on exterior surfaces. Most resins emit an odor, especially when curing. The smell of polyester resin is particularly unpleasant. It is important to work in a well-ventilated area where plenty of fresh air can cycle through the room. You need to protect your eyes and skin from direct contact with the chemicals. It is also very important to avoid sources of ignition, especially when working with polyester resins. Vapors can be flammable and can reach dangerous proportions if the room is not adequately ventilated. To continue to determine what you need for your project, you should make your selection of a reinforcement. Reinforcements are textiles or fabrics. They are typically sold as folded packages or on rolls. There are three types of reinforcements: fiberglass, aramid, or graphite. The most important consideration when beginning the selection of all of your materials should be the proper selection of your reinforcement. Reinforcement and resin system selections are generally dependent on each other. Although all of our reinforcements are compatible with both polyester and epoxy resin, the higher strength materials are generally used with epoxy. The term which is used to describe how well a reinforcement is saturated by the resin system is wet out. Wet out refers to how easily a reinforcement takes the resin. Reinforcements which offer good wet out are desirable. The important choice when selecting reinforcement is the trade-off between cost and weight. The lowest cost materials typically offer the lowest strength. Strength to weight considerations are the fundamental concerns of reinforcement selection. Chopped strand mats are low cost and easy to work with. They are the most commonly used fiberglass reinforcement. Woven roving is bulky and awkward, but is ideal for low-cost situations requiring rapid buildup. Large and flat areas are best for using woven roving. Woven glass fabrics offer the widest selection of choices. The considerations are weight, bulk, strength, and surfacing characteristics. Lightweight fabrics, such as 3/4 ounce, 2 ounce, and 4 ounce fabrics, are best for surfacing applications. Medium weight fabrics, such as 6 ounce, 7.5 ounce, and 10 ounce, are commonly called boat fabrics and offer strength, build-up, and are easy to work with. Heavy fabrics, such as 20 ounce fiberglass fabric, are not easily formable. These are typically used in high-strength applications where weight is not a factor, such as mold building. This is considered a tooling fabric. There are also high-strength fabrics which are woven in tight patterns or use special fibers, such as S-fibers, to make extremely strong glass fabrics for the weight involved. Aramids are a type of synthetic reinforcement. Kevlar is the most commonly known type of aramid and has gained the widest market acceptance. Kevlar is actually a trade name of the E.I. DuPont de Nemours company. We consider it a privilege to be an authorized distributor of Kevlar. Because Kevlar is used in many bulletproof applications, quality control is extremely high. Even the slightest imperfection constitutes second quality. We continually shop sources for second quality Kevlar, which offers the high strength, low weight benefits to our customers at a considerable savings. Kevlar is the most widely accepted synthetic reinforcement. It offers impact strength and low weight to critical applications. Kevlar is available in a veil, which is ideal for surfacing and repair applications. It is also available in lightweight woven fabrics. Graphite fabrics have gained widespread attention in the last several years. The amazing strength-to-weight ratio of graphite laminations is unequaled for most applications. Graphite fabrics consist of carbon fibers woven into a blanket reinforcement. A single or double layer can equal several layers of fabrics. Graphite fabrics frequently replace metals because of their ability to offer strength over a long, thin area, such as an airplane wing. These expensive and exciting fabrics are typically used in aircraft or other weight-critical applications. Glass mats and fabrics are white, Kevlar is gold, and graphite is black. You might recall that the stealth bomber is black, reflecting its graphite construction. Graphite fabrics are also highly electrically conductive, which must be remembered when constructing radio-controlled aircraft or other parts which are close to electrical currents. Graphite fabrics are usually rather bulky. The continuous strand veil we carry offers a surfacing alternative to this problem. Glass, aramid, and graphite can be both difficult to cut and irritating to the skin. Special scissors are usually required for cutting these fabrics, and gloves should also be worn when handling them. Most people watching this video will be concerned with either a repair application or a part fabrication. In either case, the resin and reinforcement will be selected according to cost and strength to weight. First, we'll consider a repair application. The first step of a repair is to assess the damage. Damage is usually in one of the following areas. First, surface or cosmetic only. Often painting is a better solution than a fiberglass repair. Second, fracture or gash. Often these repairs are best accomplished with putty filler and reinforcement backing. Or third, a hole or other structural damage. The objective of a repair is to restore the object to as much of its original integrity as possible and usually considers the final appearance of the finished repair. Fillers are often used in non-critical repairs. The fillers are added to the resin to offer thickening and sanding characteristics. Often, the resin is converted to a putty for filling cracks or small holes. Although fillers do not offer the same strength characteristics as textile-type reinforcements, the variety of choices of fillers can often offer suitable strength for small repairs. Additionally, sandability must be considered, and fillers such as talc can help make resin much more sandable. Fillers are often used to extend resin and sometimes to reduce the weight of the resin. Pigments may also be added to the repair putty or filled resin. Remember, pigments are added only for color. If a repair involves critical or structural damage, you might wish to consider not repairing it yourself if you have never done fiberglass work before. Although the techniques are not difficult, the importance of a properly repaired area might require professional training. Commonly, tapes are used to selectively reinforce areas such as gashes or fractures. Tapes are narrow strips of fabric. They are much easier to use than slitting the reinforcement yourself because the woven edges prevent fraying. Fillers and tapes are commonly used in repair applications. We offer several books and brochures which offer more detail about specific repair techniques. Making a fiberglass part is usually done by one of two methods, molding or laminating. Laminating is the process of applying resin to the reinforcement. In its simplest form, any method of getting the resin into the reinforcement accomplishes the job. Many applications where weight is not critical are quite adequately accomplished by simply pouring the resin onto the mat or fabric and working the two together with a saturation roller. Other common tools are the squeegee and brush. As weight becomes more critical, more care is taken to measure the weight of the reinforcement and to use just enough resin to saturate the reinforcement. Remember the example of wood as the original composite. The sap holds the fiber together, but there is very little excess. This is the same objective of weight reduction in composites. Most laminations begin with a surface layer of resin. Mohair rollers are typically used when applying resin to a large area. It is important to select tools such as rollers or brushes, which are designed to be used with resin rather than paint. Household versions of these items will often break down in resin. The most common fabrication technique is molding. Molding refers to the process of pulling one or more parts off a mold. Each part is then identical, and the process allows control of the thickness, finish, and weight, especially when making more than one part. Molding begins with the creation of a plug, which is the thing one wishes to duplicate. Plugs can be the real thing or a cheap imitation, such as foam or plaster. The plug is then waxed and prepared for the creation of the mold. The mold is constructed to allow numerous parts to be pulled and is typically much heavier and thicker than the parts which are to be pulled. There are additional techniques to further reduce weight when laminating or molding, such as sandwich core construction and vacuum bagging. Sandwich core construction involves using a lightweight core, such as polyurethane foam or honeycomb, and fiberglassing the outer skins. This makes for a much lighter part than if reinforcement layers were used throughout. Vacuum bagging is a technique which is used to reduce weight and increase proportionate strength by squeezing out excess resin. The technique does require a vacuum pump and a reasonable amount of dedication, but can be done by anyone who seeks to maximize the efficiency of their part. Future videos will focus on molding and vacuum bagging techniques. Fiberglass allows the ordinary person to make things. Although there is a lot to learn at first, practice will bring skills to high levels very quickly. Let's review the basics of fiberglass. There are two components, the resin and the reinforcement. Resins are liquids which require a hardening agent, and reinforcements are fabrics. When the resin saturates the reinforcement and then cures, it becomes a hard, reinforced plastic. In addition to the resin and reinforcement, there are fillers and pigments which can be added to the resin to achieve color or to make the resin thicker and more sandable when cured. There are a variety of tools used in fiberglass work. Remember that many household containers and tools might break down when used with resin, and that it is best to purchase tools and supplies which are designed to be used with resins. When selecting tools and supplies, you will need, first, things to mix in, mixing containers. Second, things to mix with, sticks and paddles. Third, things to measure with, measuring cups, syringes, scales. Fourth, things to apply resin, rollers, brushes, and squeegees. And finally, things to cut fabric and trim the molded part, scissors, and saw blades. You will also need to be prepared for cleanup. Acetone is the most common solvent used to clean up tools, but many tools are considered disposable and can be thrown away. Acetone works well on resin that has not been allowed to cure, but does not help if the tool has hardened. Acetone is not recommended for contact with skin. The best way to avoid this kind of cleanup is an adequate supply of gloves. Resin and glass can be very irritating to the skin. Gloves should be worn at all times. Goggles and protective clothing should also be worn when working with fiberglass. Additionally, be sure to work in a well-ventilated area. Avoid all sources of ignition and keep children away from the work area. Be sure to ask for a material safety data sheet on any of our products. You might also want to consider wearing a respirator or dust mask. Dust masks are not helpful in avoiding breathing vapors and should not be considered adequate when working with resins. There are a variety of books and brochures available to help with specific projects. Also, be sure to check with us about availability of future videos. I hope that this introduction to fiberglass has been helpful and that we have another opportunity to work with you to help make your project and ideas happen. We are happy to work with you to select the right products for your project, and we'll show off more pictures in future videos and advertising. Good luck on your project, and we hope to see a picture of it soon.